All right, tonight we're going to talk about constructing parallel and perpendicular lines when you come into class on Friday. For those that weren't here yesterday, or today actually, it'll be yesterday tomorrow, you will take your vocabulary quiz and do your notes for 3-5, and you work from the 3-5, and then you'll work on constructions also. So you all be in a separate group to yourselves. We're going to talk about tonight about constructing parallel and perpendicular lines. So first thing you need to do is do your vocabulary review, answer the 2 true-false questions, and tell what kind of angles are in 3, 4, and 5. And our vocabulary word for today is constructions. We've already done constructions, but construction means how to build something or something is built or constructed. So when we do a construction in geometry, we use a straight edge and a compass to either create parallel lines, perpendicular lines, angle bisectors, etc. So you're going to use the word construction or forms of the word construction for question number 6. And then we're going to continue on at problem 1, constructing parallel lines. All right. The diagram at right shows the construction of line M through point N with line M parallel to L. So we're going to find out why are L and M parallel. All right. Now we learned previously in a theorem that through any one point there is only one line that is parallel. So the diagram shows the construction of congruent angles 1 and angle NHJ. And should probably be an angle sign on there, but we're just going to go NHJ. All right, so circle the description of the angle pairs that were constructed. The angles are congruent and they are corresponding angles. Because we created congruent angles, we created 2 angles that were congruent, and then that means the line we drew between those angles will be parallel lines. So I know it's hard to look at a construction when it's completed and say what exactly were the steps to get to that. So tomorrow we will construct parallel lines and we'll all have drawings like this when we're done. So why must L and M be parallel? We constructed a transversal to form congruent corresponding angles with lines L and M. So L and M are parallel by the converse of the corresponding angles postulate, which is postulate 3.2. Continuing on, we're going to do a construction of a special quadrilateral. We want to draw a segment, label its length M, and construct quadrilateral ABCD with AB parallel to CD so that AB equals M and the distance from CD equals 2M. So this is a special quadrilateral we're going to construct. We're going to do this one tomorrow also. So number 10, we're going to underline the correct word or symbol to complete each sentence. Construct parallel lines, because we want 2 lines, A, B, and C, they're parallel. We're going to draw a line AB. We're going to draw point D, not on AB, and then we're going to draw AD. The length of segment AB is M. So we're going to see all this here in the next slide because I'm actually going to do the construction for you. At D, we're going to construct angle TDZ congruent to angle DAB so that angle TDZ and DAB are corresponding angles. Therefore, DZ and AB, those 2 lines will be parallel. Now you need a side of length 2M, and we're going to construct C on DZ so that DC is 2M, and we're going to draw a line BC. So it's easy when we hear a bunch of words, so let's put those words into action. We have segment AB. The first thing we're going to do is draw line AB. Once we draw line AB, we're going to draw a point D, and we're going to, that's not on AB, and we're going to draw a line AD. The length of AB is M, so that's given in our drawing already that AB is M. At D, we're going to construct angle TDZ congruent to DAB. So you draw an arc there, we go up to D, and we draw the same 2 arcs. All right. We use the same distance. Get the pointer out, the good old pointer. All right, we're going to use the same distance here and here to create the arc. I know it doesn't look like it on the PowerPoint, but it's going to be the same distance from here to here to here to here, and that'll give us our parallel lines. You create two corresponding angles. So once we have drawn that distance, get my regular pointer back. All right, now we're going to draw our lines which are parallel. So line that contains point D now is parallel to line AB. We could put a point on there Z. I didn't do that, but you could put on there Z, and line DZ would be parallel to AB. So now we want to create point C that is 2M. So we have to take our compass and put an arc there on B like I did, and we go up to the line above and we draw that arc, and then we're going to draw it one more time, and that gives me 2M, and that is point C. So I probably should write, so we know what line we're dealing with here. This is point line Z. Of course, it's coming up in white, so it's kind of hard to see. That's point Z. And so the last thing I'm going to do is I'm going to draw segment BC, and that is our special quadrilateral that we're trying to construct. Again, we're going to do that in class tomorrow, so be prepared to construct the special quadrilateral that meets the description in the notes. All right, let's look at perpendicular lines and perpendicular at a point on a line. All right, we're going to use a straight edge to draw EF, construct FG so that FG is perpendicular to EF at point F. So we're looking at the diagram on the left. I know it's hard, right? It's harder to go from a diagram that you've already seen the construction and figure out exactly what was done in the construction. But the first thing we had to do was draw a line and label points E and F. So we did that, draw a line, and we had 2 points E and F. Now we're going to make the compass opening EF. And with the compass tip on point F, we're going to draw an arc that intersects the line twice. Mark one point H. All right, so that we have EF equals FH. What we've done is created a segment on line EF such that in the segment EH, EF or F is the midpoint of segment EH. Now we're going to make the compass opening greater than 1/2 EH. So it has to be greater than the distance from greater than 1/2 the distance from E to H. And I'm looking at their drawing and I'm not seeing how that distance is actually that big, but we're going to make a compass greater than 1/2 EH. And with the compass tip on E, we're going to draw an arc above the point F. Well, that makes sense now. Yeah, it's greater than EH. We draw the point on F. Then we're going to put the compass point on H, and we're going to draw an arc that intersects the arc from step 3, and we're going to label that point intersection G. So, hey, it didn't look like it for me, but when I think about what they did, they took the compass point, put it on E, drew an arc above the line. Now, remember that purple line's not there yet. They put that point on H. They drew the point above the line. And then eventually they drew the line FG. So they draw FG, and then that's how we get a line that is perpendicular to EH. And what we have created here is a perpendicular bisector of segment EH. Continuing on, we're going to look at the perpendicular postulate, which is postulate 3-4. Through a point not on a line, there is one and only one line perpendicular to the given line. So if we look at our diagram below, the example of this would be example in the middle. There is given a point, there is only one point perpendicular, given a point above a line, there is only one line perpendicular to the given line. So if we look at our problem for perpendicular from a point to a line, we're going to kind of do this construction together. So we're going to open our compass to size greater than the distance from Z to line L. With the compass tip on point Z, we're going to draw an arc that intersects line L at 2 points. So there's my arc. Your arc's going to be better than this. This is the best I could do with what I got, but that gives you an example of what you need to do. You're going to draw the arc. Okay, now we're going to label the points C and X. So there's C and there's X. We're going to place the compass point on C and make an arc below line L. So there's my line L. Now, we take the same opening, very important, don't let your compass change. Take the same opening and the compass tip on X and draw an arc that intersects the arc you made in exercise 21. And we're going to label that point of intersection B. So again, I didn't do that, so I need to go back and correct my pen color. Let's get that set straight first, red. And pin, all right, we're good to go. We're going to label that point B. All right, it's my nice little B there. So now we're going to draw line ZB. Okay, and you'll have to beg me. I couldn't get it right on that point, so theoretically that is a perpendicular line going through line L. So we're going to use line L and point Z at the right, construct a line through point Z perpendicular to the line L. And that's exactly what we did step by step. That line ZB is perpendicular to line L, or line CX. So for the rest of the video, you can check your answers to your original problems in the beginning. And so that you can do that now. And there's the review for the first part. True, false, alternate interior, corresponding alternate exterior. There's a vocabulary word and our verbs construct, construction, and constructive. And now I need you to do the lesson check. Suppose you use a wider compass setting in exercise 18. Will you construct a different perpendicular line? Explain. So I want you to think about that. Will you do it? And I have the answer on the next slide, but I'm not going to show it till tomorrow. So you think about that and write an answer. I hope you have a good evening, and I will see you tomorrow on Friday for school. Good night.